Alright, people, I believe we are live. Welcome back to The Alchemist by an Academy. My name is Pahul. And if I'm audible and visible, please write here in the chat box. You know exactly what the drill is. Yes. Alright, dosto. So, I am pretty sure there are going to be a lot of new people over here in today's class. And welcome to The Alchemist. Now, for the first few minutes of today's session, I'm going to give you some information, a little bit of information about Unacademy and a little bit of information about how this course on YouTube will work. Okay, so शुरू के जो 3-4 minutes है, the beginning 3-4 minutes of this class is just going to be some information for you, and then we will get into the meat and potatoes of today's class. I am not planning to take this to a very long session today. Okay, trying to cut it short into 45 minutes. All right. Audio is not good, let me check. Okay, 1 second. Hello, check. Is the audio better now? There was some problem with the audio preferences over here. I think it should be better now. Okay, anyway, let me introduce myself to you. My name is Pahul and I am an alumnus of IIT Bombay, and I have been teaching chemistry for a very long time now. I've taught chemistry so many times that Manan Sweeney today was asking, sir, don't you get bored teaching the same things again and again? Teaching the same things again and again is a little boring, but the thing that makes it interesting is that every time I teach a concept to students, the students out there are new. Yeah, so I am hoping that a lot of you students are new to this channel, new to my teaching. So before I get into today's course, okay, let me quickly tell you about Unacademy, then I'll tell you about my teaching style, then we will get into the idea of learning about the discovery of electrons, cathode ray experiments. One thing, a lot of you would have noticed that in the first 2.5 minutes of this session, there was just music playing and there was just a picture on the screen. You know why? Yeah, why do I keep the first 2.5 minutes of the session just like that? Imagine yourself in an offline class, okay? Imagine you're attending a class in a nice, reputed coaching institute. You sit there in that class and you talk to the students next to you, isn't it? You talk to your classmates, you talk to your fellow batchmates, yes? And then 2 weeks, 3 weeks later, you start becoming friendly with them, and 1 month, 2 months later, you become really good friends with a lot of people in your class. That's exactly the goal of this session as well. Okay, Lakshmi is saying it's for relaxation, not just for relaxation. It's so that we all can, talk to each other, get to know each other very well in the chat box. Thankfully, that is possible, right? So one thing that I would love for you to do is, in case you are someone who's actually serious about preparation, let me tell you, solving questions is very important for your preparation. All right, IITJ preparation, solving questions is the most important thing. So if you want to solve more questions, join the Unacademy Combat Test Series and the IITJ T20 Test Series. Links in the description box down below. If you can't find the links in the description, you can simply do a Google search like T20 Unacademy. Fine. And if you want to enroll in these for free, you can win scholarships as well. Yeah. You just use the code Pahul. That's my name, P-A-H-U-L. All right. ठीक है? Also, we have this offer going on. Very nice offer. For a lot of you who are 11th class students, if you want to take a 1-year subscription or a 2-year subscription, there's 2 months free and there's 3 months free respectively. Yeah. Plus subscription is one of the best offerings in online world right now, because we have the best of teachers of the country teaching over here. I always recommend you books. N. Avasthi for physical chemistry. Yeah. O.P. Tandon for inorganic. V.K. Jaiswal for inorganic. M.S. Chauhan for organic chemistry. N. Avasthi, V.K. Jaiswal, M.S. Chauhan, these people are actually teaching on Unacademy Plus. It's a coincidence, okay? I'm not recommending their books because they teach on Plus. I've always been recommending their books. Even when I was not in Unacademy, they teach in Unacademy Plus. So if you want to learn from the best of teachers of the country, you have access to unlimited courses of Unacademy. You can go for the mega subscription offer. And how to enroll in it, just go to Unacademy's app or website. You will be able to follow things over there. If you subscribe for 12 months, the price is less than 3,000 per month and you will get 2 months extra on this. Yeah, so that's beautiful. In case you want to unlock the maximum discount, PAHUL, Pahul is the coupon code. These are the pricing details for the Plus course. These are for the Iconic course. In the Iconic course, we will give you a personal mentor as well. That's all. Okay, personal mentor milega. You will get a lot of more tests, a lot of more study material. So the personal mentor will take care of your preparation from the top to the bottom. Okay, so Plus subscription, Iconic subscription, whatever suits your fancy, you can join it. Coupon code is PAHUL, Pahul, for the max discount possible. If you need more details of the Plus subscription, I will tell you in the session and towards the end part of today's session. You can follow me on Instagram and Unacademy. At both the places, my ID is Pahul PSG. Yeah, this is just for you to follow me on my personal platform, Instagram, personal profile. Unacademy pe you can actually send me messages and ask me whatever you want. Chalo ji. Now let's come to this particular course. Yeah. First rule of my live classes is that it has to be interactive. Okay. First rule of my live classes is that it has to be interactive. We'll focus on studying chemistry while having conversations. Conversations are very important for us. Okay. This is not your usual. I'm not a usual teacher. Okay. I'm not someone who's like, okay, this is formula, remember formula, E equal MC square, ratto. No, I'm not going to do that. All right. I'm not going to do that. We are going to have conversations, and while having conversations, gappe marte hue. All right. While having these conversations, we learn so many things about chemistry, we won't even realize that we are in a class. Okay. That's the thing about this course. It's just about conversations. Also, this course is from the very basics. Yeah, which means that in this course, we won't go very fast. This course is going to be slow and steady. Alright, don't expect me to go too fast in this course. There is one option. If you want to learn very fast from me, then you can watch the live session as a recorded session next day. Yeah, watch it at 2x speed maybe. Slow and steady is what's our philosophy over here. Fast and furious nahi karenge apan. Fast and furious we'll do it later when we are close to the examination, when we are solving questions. Okay, so conversations, it goes from the very basics. The classes definitely will be in English. Yeah, that's the unique property about this channel, that the classes over here are in English. On Unacademy JEE they teach in Hindi, so we've got a nice balance. Okay, fine. Lingaraj Gowda is asking about, sir, handwritten notes. You have to make your own notes. Alright. You have to make notes. A lot of channels out there promise that they will give you PDFs. You will get handwritten PDFs by the teacher. The teacher does not have to take the examination. You have to take the examination. If you are not putting your own efforts with your own hands, writing your own notes, then trust me, there is no use. Because whatever I will teach today in, let's say, 10 slides, you can write that on your notebook in just one page. Okay? Revising one page 1 month from now, 2 months from now is easier than revising 10 slides. And especially when you write things on your own, your brain works. And automatically things get fed into your brain. Okay? So please promise me that you have to make your own notes. Okay? Please promise me that you will make your own notes. Alright. Now a lot of you must be asking, sir, what about questions? From where can we do questions? Yeah. What about questions? I'll tell you the source of the questions. Okay. Sources of questions will be given. Understood? One more very important thing over here is that you guys have to read the NCERT. This is very, very important, okay? Why is it important? It's the government prescribed book. The syllabus of JEE is defined using the NCERT. So if you're studying the NCERT and attending my classes, you will become an expert in the chapter in no time. Whatever chapter we are doing, you have to read the NCERT. You can read the NCERT's, 5-6 pages related to the class after the class or before the class. It's totally your call. I would suggest you do it before the class, but it's fine. ठीक है? बढ़िया. ये must है. And one more thing, that this particular series of classes is starting for 11th class students. Okay, if you're a 12th class student, you might find this very boring because you've already done it earlier. Okay, Kaustav is saying, sir, can Iconic subscription have access to? Yes. So cost of Iconic subscription is plus subscription with personal mentor. Yeah. So DC Pandey sir is on Unacademy Plus, and if you subscribe to Iconic, you can actually access his courses as well. Yeah. Okay. So again, the code for the maximum discount is PAHUL Pahul. Fine. So JASW Jaswant, sorry, there was a space in your name, couldn't read it properly. Jaswant is asking, should we read NCERT and then come to your class? Preferably yes. Okay, so this is about the course. Fine. And once again, I will keep chatting with you, I will keep having these conversations with you, but sometimes I'll be more focused on the board, I'll be more focused on the camera, so I might not be able to reply to all of the chat messages. I'm pretty sure that is obvious. Chalo. Now let's come to the discovery of the electrons. First of all, tell me, can air conduct electricity? Yeah. Now we are starting the conversation. अब अपन गप्पे मारेंगे, and while having these conversations, we learn so many things about chemistry you won't even realize. चलो ये बताओ मेरे को. What do you think? Does air conduct electricity? Yes or no? Sai is saying no, it's impossible. Python God is saying no, it's impossible. Arbaz is saying yes, it can. Ashutosh is saying yes, it can. Ankit is also saying yes. Lakshmi is also saying yes. Krishna, it happened in the beginning of this month, bro. Welcome. Yeah. So some people are saying yes, some people are saying no. Dekho, if you guys are saying never, then that is definitely an incorrect answer. Air can conduct electricity. It is dependent on the kind of conditions that we have, isn't it? What conditions exist for air to conduct electricity? Can you tell me? What would be the conditions? Let me give you a hint. Hint is, think about the rainy season. What happens in the rainy season when it's raining cats and dogs, when there is a thunderstorm outside? Yeah. What happens in a thunderstorm? In a thunderstorm, there is an electronic discharge. That's what we call it. Yeah. Some sort of a circuit gets complete between the clouds and the earth, and there's must take them lightning. So what are the conditions in that case? उस टाइम पे conditions क्या होती हैं? I can see Sarvesh very nice, Rishi very nice, बिल्कुल बिल्कुल, Sai very nice, good job, Tanish very good job. A lot of you people are giving me the absolutely correct condition. The condition is low pressure. Yeah, you know, during rains the air pressure decreases. You have those barometers as well telling you that it can rain, isn't it? So like low pressure, and of course there has to be a significantly high voltage, very high voltage. Yeah. So what we want to do now to understand the cathode ray experiments is to create this atmosphere inside the laboratory. Okay. How does chemistry work? Chemistry works, we do experiments, we write some observations, and then we try to give some theory, give some logic to those observations. Yeah. Multiple observations we'll get from the experiment. We'll try to tie down these observations one with each other using some logical reasoning, some logical explanation. So this is what we want: low pressure and high voltage. By high voltage, you can say high potential difference. Yeah, that's the better way of telling about it. High potential difference. Okay. Abhishek is saying, can this lecture work for NEET? Absolutely yes. Okay. This lecture is applicable for JEE students and NEET students. Same. Okay. JEE, NEET, jo bhi hai, same syllabus, same lecture, works perfectly. Okay. Now, my dear friends, the way the scientists, yeah, J.J. Thomson and William Crook, these were the two people who did this experiment. Thomson and Crook, you can remember. Even if you don't remember, it's fine. The way they created this condition inside the laboratory is they used an apparatus which they themselves designed, known as the Crookes tube. Okay. As soon as I say tube, I'm pretty sure you have some sort of an image in your mind which looks like this. Yeah. Like a test tube maybe. ये test tube हो गया आपका. Yeah, just kept it like this. Yeah. So there was a tube, and inside this tube we've tried to create the conditions of very high voltage and very low pressure. Yeah. How can we create low pressure? We can suck out the air from this. There in the laboratory there are these pumps. You've seen those pumps, small little pumps, emergency pumps बोलते हैं जिनको, which you put on your car's tire and they pump air into the tire, yeah, करके चलते हैं वो अजीब से. Have you seen those? Sarvesh is saying, is this applicable for advanced? Definitely yes. Yeah. So I'm pretty sure you've seen those pumps which you can connect to the car's tire or the motorcycle's tire, and it pumps the air into it. Yeah. But at the same time, there are the opposite type of pumps which are vacuum pumps. Using a vacuum pump, you can suck out air from this guy. Yeah. So you create a particular atmosphere over here inside this tube, which is of a very low pressure. What is low pressure? Low pressure means there's very less gaseous molecules inside this particular tube. Yeah, more gaseous molecules, more is the pressure, less gaseous molecules, less is the pressure. Yeah, so you essentially use a vacuum pump. Fine. So vacuum pump लगा के इसको हमने isolate कर लिया. Fine. And then to put some high voltage, what do we need? We need electrodes. What are electrodes? Electrodes are basically the ends where there is potential difference. Yeah. So you put an electrode on the left side and you put an electrode on the right side. बीच में यहाँ पे battery लगा दो. Done. Isn't it? You put a high voltage battery, or you do some, you use some techniques to increase the voltage of the battery, and we are done. ठीक है? Do you know of any apparatus that creates a very high voltage in a very short distance? Siddhartha is saying how to understand a concept clearly. Read about it, solve more questions about it. That's as simple as that. Okay. Krish, this is for class 11th. Okay. Do you know of any apparatus that creates a lot of potential difference in a very small length? Sai and Rishi, very nice. Very nice. I'll try to draw an image of that. कुछ ऐसा सा दिखता है वो. Remember that? Remember that Tesla coil? Yeah. Tesla coil में एकदम से there's a lot of electricity discharge that is created because there's a lot of potential difference that you can create in a very small form factor. चलो ठीक है. So this is what the Crookes tube actually looks like. These are images that I've picked up from the internet, of course. Yeah, in the light, in the dark, and you can see the experiment is running over here, and something is happening in the middle. यहाँ पे कुछ दिख रहा है आपको होता हुआ? Can you see these bluish colored rays that are going like this? And then this particular surface is getting colored. Can you see that? Soumya, it actually already exists on YouTube. Please check it out. Okay. JEE vlog is saying, how long will the class go? Today's class, we will try to wrap it up by 7:50. 7:50, 7:55. Yeah. ये देख रहे हो कुछ तो हो रहा है यहाँ पे. So there's some sort of a ray that is getting produced over here, and then there is some luminescence. Luminescence बोले तो presence of this sudden light, okay, which is present over here. Yeah. There's something that glows over here, and there are some rays that come over here. ठीक है? So when this experiment was done, all right, when this experiment was done, let's try to draw the thing over here. Fine. When this experiment was done, let's make this tube. Okay, we can make a uniform looking tube. We don't need to make it exactly the way it is over here. Fine. Let's put the two electrodes. Now this is a diagram that you should draw. This is something that you can find in the NCERT as well, but this is something that you should draw. Okay. So let's say this is the negative terminal, and let's say this is the positive terminal. Cathode, anode, is that fine? Can you tell me negative वाली cathode होगी या positive वाली? Which one is cathode? I'm pretty sure you know what it is. And a low pressure environment is maintained over here. Then when you start the circuit, okay, when you start the experiment, this is what happens. You create a lot of potential difference between the positive and negative terminal. So there are rays, okay, there are rays that start from the negative terminal, that is the cathode. Okay, ये जो cathode है, from here there are these certain rays that start moving over here, and those rays can be observed. ठीक है, these rays can be observed. Can you see them over here? यहाँ पे दिख रही हैं आपको? Yeah, can you see them over here? There are these rays that start moving from the cathode towards the anode. So that is why when the experiment was done, it was observed that the rays start from the cathode. Therefore, these are known as cathode rays. Yeah, everyone understands why these are called cathode rays. Cathode ray experiment, because when they did this experiment, when they created this thunderstorm inside the laboratory, the rays actually started from the negative terminal. We call them cathode rays. Done? Okay. Now, Sai is asking, Sai Madhisetti is asking, sir, why does the Crookes tube have such less pressure? Why is the Crookes tube evacuated of most of the gas? Can you guys answer this question? Why low pressure? Also, tell me, which gas should I use for this particular experiment? सोच सकते हो? Why low pressure and which gas should I use for this experiment? And to get your answers in the chat box, it takes me like 10 seconds or something. So please wait while I get your responses. Yeah. Jaswant, I know it is because of the vacuum pump, but why? Why is there low pressure? Why did we want low pressure? Why couldn't we just do it in normal atmospheric pressure? Rishi is saying less pressure gas can easily be ionized. We saw that reason earlier. Hai ki in low pressure conditions, gases can easily be ionized. Number one. Number two is, let's say there are gaseous particles over here and there are rays that are flowing from the cathode to the anode. If there are too many gaseous particles inside, it is possible that the rays interact with those gaseous particles and something else happens. Yeah, it becomes all haywire. To avoid collisions, Mr. Autonomous is giving the very correct explanation. To avoid collisions, essentially. Yeah. Have you seen how electricity looks like when you have a discharge from the cloud to the earth? Zzz, aisa kuch. Do you want zzz to happen in the experiment? Not really. You want as straight rays as possible, isn't it? You don't want the rays to go and do this. If there are too many particles, there is a lot of probability of this happening. Takra ke kuch na kuch. Something will happen. Yeah. You want the least amount of deviation in the rays path, because if the rays are going straight, I can actually observe them. I can actually do some experiments on them. Yeah. Bilkul sahi, isn't it? So cathode rays, when the rays start from here, they go towards the anode, and you can see that these are the rays that are coming out. Now, rays mil gayi. We know what these rays are, but we want to understand the properties of this. Yeah, we want to understand the properties of this. So the first property that I can think of, yeah, low pressure apne ko samajh aa gaya, you don't want collisions, it's easier to ionize the gas at low pressure. And which gas did we take? You can actually take any gas. Okay, you can actually take any gas over here. You can take whatever gas, you can take the heaviest gas possible. Yeah, you can take a very heavy gas like SF6, it'll be fine. Sulfur's hexafluoride. Okay, it's a very heavy gas. You can take any gas, the experiment will work, but it will be the easiest in the case of hydrogen. Yeah, again, because hydrogen gas molecules are very small. And if you have to do anything to the gas, hydrogen gas is the easiest to obtain. It's the easiest to do experiments on, it's very light, so on and so forth. So you can use hydrogen gas in the laboratory. If you don't have hydrogen gas, you can also use helium gas. That will be pretty much the same. But this experiment can be done with any gas, theoretically speaking. Practically, you use only a certain type of gases because it's easier to do an experiment with them. Understood? Chalo, ye ho gaya. Now, the first property of these rays that comes to my mind is that since they are going from a negative side to a positive side, can I say that, okay, if I am the scientist who's doing this experiment, there's a ray going from the negative side to the positive side. Does it mean that the rays are charged? Can I say that the rays are charged? Interesting, maybe. Maybe I can say that. Maybe I can say that. And since they are going from the negative side to the positive side, I can also say that, acha, these rays are, let's say, negatively charged. Right now, this is just hypothesis. Do you understand the meaning of the word hypothesis, whatever you want to call it? Do you understand the meaning of the word hypothesis? Hypothesis is something that you propose that, okay, this is possible. You don't know it yet. It's just a hypothesis. Yeah. For example, I can say my hypothesis is that COVID virus will leave we will be done with the COVID crisis in 2 years from now. That's my hypothesis. How do I verify it? I have to actually wait for the end of this crisis. So hypothesis is something that you propose that, okay, this is possible. Then you do experiments on it to understand whether that makes sense or not. It's assumption. It's conjecture. Okay. English with Pahul sir. I use a lot of weird words of English. One word that I just used was conjecture. You can check out the meaning of the word conjecture. It essentially means an intelligent guess. Conjecture is just a guess, but it's an intelligent guess. Okay. So right now, being negatively charged is just conjecture. It's just hypothesis. It is something that I have to verify. How do I verify that a particle is negatively charged? You guys tell me. What are the ways to verify whether something is negatively charged or whether something is charged? Sai, I'll come to that. Don't worry. Okay, step by step. Bhavi is saying, can I take NEET without biology in 12th? You cannot. There is no point of it, man. You have to clear the cutoff of biology as well. Nitin is saying, ek bar kaho, welcome to the world of sarcasm. Yo. Sangi, actually, I am teaching every day, but I have to take classes for you guys, for 12th class students, for people who are just preparing for, JEE 2021. So, I'm teaching different groups of people on different days. Okay? Acha, very nice. So, a lot of people are saying, sir, put some electric field or magnetic field and it will start deviating. Absolutely. Correct. Yeah? That's absolutely correct. If I put a magnet, yeah, iske aaspas main ek magnet rakh do, let's say. Imagine my hand is a magnet. Yeah, this is a horseshoe magnet. If I keep a magnet like this, the negatively charged particle, if it is a negatively charged particle, it will deviate. Yeah, it will go in a certain direction. If I apply another electric field, assume that this pen and this pen are electrodes. If I put electrodes around it, then definitely the rays will move. There is one more very interesting way of ascertaining whether these are charged particles or not. Negative charge you can ascertain by seeing its deviation in electric field. Yeah, if it goes towards the positive side, it is a negatively charged particle. Great. So I can put electric field or magnetic field around this so the rays can bend. I will show you an image. I'll show you a visualization of that very soon. Chalo. Anyway, the truck agrees. And yeah, so there is one more very interesting way of ascertaining whether this is a charged particle or not. Ek bahut interesting tarika hai. We put a certain type of a screen over here. Okay. So instead of taking a specific electrode, instead of taking a blocked electrode, we take a perforated electrode. Perforated electrode bole to, there are holes in this particular electrode. Yeah, the anode that we take has holes in it. How can we have these holes? Let me make the front image of it. Aisa kuch. Yeah. This is your anode. Yeah. You've kept this anode over here. Why? So that the rays, some of the rays can pass through the anode. Alright. Does this look familiar to you? I am pretty sure you've seen this shape in your washroom, or maybe you've seen this shape in your kitchen when you're frying something. Yeah. So these holes, these empty spaces that I've made over here, these are called perforations. Anything that has holes in it is called perforated. Alright. So the anode that I've taken over here is a perforated anode. Fine. The anode has perforations in it. Why so? Because I want the rays to pass through those perforations. यहाँ से pass कर जाएंगे, मस्त एकदम, chill. And when they hit this specific screen that I've made, the screen starts to glow. Yeah, the screen, I'll draw the glowing in black color. Okay? The screen starts to glow. Now, if you guys have, yeah, this is something that you've seen in the shower every day. I'm sorry. Yeah, very clear. Yeah, shower heads are perforated. Very nice. Cool. So, what is this screen and why does this screen glow? Does anyone know what the screen is? If any one of you has read the NCERT, किसी को याद है ये कौन सी screen है? Yeah, Lingaraj Goda, I'll come to the pinwheel as well. That's fine. Rishi is asking, so why does the screen glow? Yes, I will tell you. Does anyone know what compound the screen is made of? Yeah, Rohan has read it already. Tanish and Ahmed and Ashutosh, a lot of people have read it already. That the screen is made up of zinc sulfide ZnS. And ZnS has a certain property. ZnS has a certain property. Okay. ZnS is a चलो आप बताओ क्या है. ZnS essentially glows when a charged particle hits it. What is that property called? Okay, ZnS is a screen, ZnS is a compound on which if you hit a charged particle, अगर मेरा charged particle ZnS पे hit करता है, then the ZnS screen will glow. That is a property of the glow, sorry, not grow. It will glow, and that is a property of the zinc sulfide screen. What is that property called? A lot of you are saying that, sir, it is fluorescence, sir, it is phosphorescence. There is a difference between both of these two terms. Okay, so my first assignment for all of you, okay, this is going to be an integral part of our class. We'll keep having these fun assignments. My assignment for you guys is read about it. You can use Wikipedia to do so. I live next to a highway, people, so there will be random noises of traffic coming again and again. Harsh is saying, should we take dummy school in class 11th? If there is an option of taking a dummy school, then you should take a dummy school. That's my suggestion. Okay, read about it. Okay, phosphorescence and fluorescence are two different properties. They are from a same bracket. Okay, but why does it happen? What does this charged particle do to zinc sulfide? What happens inside zinc sulfide? What's the difference between fluorescence and phosphorescence? The property of zinc sulfide, is it fluorescence or is it phosphorescence? You have to essentially read about it. Okay, so this is your first assignment of today's class. What is zinc sulfide? You have to read about it. You have to read about it on Wikipedia. You need to know a little bit of details about what is fluorescence, what is phosphorescence, etc. etc. Understood? Okay? Chalo, badhiya. So till now we've understood exactly how the experiment was done. Okay? Till now we've understood exactly how these experiments were done. Now, tell me one thing. Okay, just one more thing, and then I'll show you a visualization of this, and then I'll tell you why this led to the discovery of electrons. Okay, this is my cathode ray tube. Very nice. My cathode rays are going from the cathode to the anode, negatively charged side, positively charged side. Same diagram again. Now, let's say I put a magnetic field across it or an electric field. Yeah. Okay. So these panels that I have put, these are also, let's say, electrodes. Fine. Because of these electrodes, the rays will start getting curved now. है ना? ये curve होना शुरू हो जाएंगे. I'll show you an image of how these get curved. Don't worry. They'll get curved like this. Right. So they'll curve in some certain direction. Now, okay, let us say that the particle that is moving inside this ray is of 1 unit mass. Okay, some mass. Okay, the mass is very small, that's why I'm not calling it 1 kilogram or 1 gram or 1 milligram or 1 nanogram, nothing. I'm just saying that it has 1 unit mass. Okay, some unit, imagine it in your mind, a very small unit of mass, and this has 1 unit mass. Now another tube, same setup. Okay, another tube, same setup, negatively charged, positively charged. Okay, same electrode yahan bhi laga diya apan ne. But what I observe is that over here the deflection is much lesser. Okay, over here the curve is much lesser. Is this particle heavier or lighter than this particle? Tell me. There are two different cases. In both the cases everything is the same, but I notice that the deflection over here is a lot, the deflection over here is very less. I say that the particles over here are of 1 unit mass. Yeah, the particles contained in the rays are of 1 unit mass. Is this heavier or is it lighter? It has to have more mass, isn't it? Because if it's heavier, there will be less deflection. Yeah, let's say you're running, okay, and there's a wind that starts blowing. You might shake a little. Let's say there's an ant that's running next to you. Yeah, ek chinti. A tiny little insect is running next to you. If the wind blows, that insect will be blown away. So obviously this guy over here is heavier. Yes. Now people, the fun thing is that if I take different gases over here, if I take different electrodes over here, listen to me very carefully. This is one of the most important revelation points of this class. If I take different gases, or let's say I take different electrodes, as a scientist, I might expect that, okay, the particles that I'm getting in the cathode rays will also be different. Yes or no? Very basic idea that, okay, if I take different gases, different electrodes, particles will be different. I can ascertain that, I can confirm that by different types of deviations. Yeah, fine. That's my assumption. अगर मैं different चीजें लूंगा, deviation different आएगा because particle different होंगे. That's the idea. Okay, that's the idea as a scientist before I know anything about the experiment. Now, why did I tell this to you? I will reveal it in the next 5 minutes. Before that, I have to show you something. Okay, ये सब मैं पढ़ाऊंगा आपको. Don't worry. I will show you something. These properties, there are 2 YouTube videos that I have taken for you. I will show these YouTube videos to you. Don't worry about the copyright. This is an educational channel. We don't care about copyright. ठीक है, तो बड़ी मस्त सी वीडियोस दिखाने वाला हूं मैं आपको. Just give me one moment. Let me load these videos on the streaming software and then we will see them. Yeah, just give me a moment. All right. In the meanwhile, if there's anything you want to ask me in the chat box, you can. Yeah. Chirag, I'm glad that helped you, man. Shubha Yoga, I will do some revision of the theory as well. Okay, the same time. Okay, so the first video that I'm going to show you, it's very interesting. Okay, and I show it to all of my students whenever I teach this chapter, whenever. Yeah. So this is what we are going to look at now. Let me open this up. Okay, so this video that I'm going to show you is from this particular channel, yeah, called My Inter Academy. Fine, full credits to them for making this video. Listen to this video carefully. इसको ध्यान से सुनना आप एक बारी, बड़ी मस्त सी है.
Cathode rays are produced in a discharge tube. A vacuum pump is used to evacuate the discharge tube. The cathode of the tube is connected to the negative terminal of the battery, and the anode of the tube is connected to the positive terminal of the battery. It was observed that, at normal pressure, the gas did not allow the current to pass through it. However, when the pressure of the tube was reduced to 0.001 mm Hg, and a high potential difference between 10 kV and 20 kV was applied, at the end of the tube, a glow was seen on the walls of glass tube. The rays emitted by the cathode travel towards anode. The attraction of rays towards anode reveals that the rays carry negative charge. Properties of cathode rays are: 1. When any object is placed in the path of the cathode rays, these rays cast shadows. This shows that cathode rays travel in straight line. 2. When a wheel was placed in the path of cathode rays, the wheel rotates. This shows that rays consist of some particle and some kinetic energy. 3. In the presence of an electric field, the rays are deflected towards the positive plate. This confirms that cathode rays consist of negatively charged particles. 4. In the presence of a magnetic field, the rays are deflected. This shows that the cathode rays are affected by the magnetic field.
Alright, did you see that one? What did you understand? We understood a few properties of these cathode rays. Yeah, Chaitanya is saying, how can a wheel be placed if the tube is sealed at both ends? You first place a wheel and then seal the tube. Yeah, tube baad mein band kar lena. Fine. So, these are the properties of the cathode ray experiment. If you want to note it, you can note it down. This is mentioned in the NCERT as well. Quickly, let's read these properties. Then let's read the properties of the cathode rays. And then let's come to the conclusion. Okay. Then let's come to the conclusion. So the apparatus used is a cylindrical gas tube. William Crookes designed it. The tube is called Crookes tube. We know that. Two metal electrodes are connected to a high voltage power supply, 5,000 to 10,000 volts. Very high voltage. Okay. Vacuum pump helps maintain the low pressure, about 0.001 millimeters of mercury. Yeah, atmospheric pressure is 760 millimeters of mercury. So this is considerably low. Yeah, zinc sulfide screen was placed behind the anode. At this high voltage and low pressure, it was observed that the zinc sulfide screen behind the anode starts glowing. The property of zinc sulfide is that it starts glowing when a charged particle hits it. I hope you are making notes, and I hope you've written this down already because I've explained all of this verbally. Okay? Shad is saying, sir, how does the circuit not melt at such high voltage? We use good conductors. And Shad, you have a very interesting, very valid question. I'll show you how this experiment is done in reality. I'll show you that very soon. ठीक है? ये हो गया, मस्त, एकदम बढ़िया. Fine. Now, these are the properties of the cathode rays. The first property is that the cathode rays travel in a straight line, and we saw that in the video that we just had a look at, isn't it? In the video they showed that if you put something in the path of the ray doesn't continue, which means that the ray is traveling in a straight line. Okay, the rays are made up of particles. How can we ascertain that? By putting a wheel inside the tube. Yeah, the wheel moves, it means that the particles are hitting the wheel, they're transferring the kinetic energy, so on and so forth. Cathode rays are made up of negatively charged particles because we ascertain that by putting the electric or magnetic field around it. Negative to positive ja raha hai, great. Cathode rays are deflected by electric and magnetic field. Cathode rays also show heating effect. Okay, this was also an assumption that if you keep something in the path of cathode rays, okay, let's say there's a metal surface and these are cathode rays. If the cathode rays, sorry, yeah, I hope I didn't kill anything. I just threw my Wi-Fi router. I hope the Wi-Fi is still working. So if the cathode rays go and hit the metal surface, the metal surface starts heating up, which essentially means that these particles are capable of transferring energy to some other particle, essentially. ठीक है? Fine, ये हो गया. Cathode rays produce X-rays on hitting a metallic target. Now, this is something that needs a little more advanced knowledge. We will understand this particular line later. Okay? Later. When we do the Bohr's model of the atom, when we do photoelectric effect, this is something that will be very obvious to you. Okay? When we do photoelectric effect and Bohr's model of the atom, this point will be very obvious to you. You can think about it later. And the last thing is very interesting. Cathode rays ionizes the gases through which they travel. My dear friends, this last point is very interesting. First of all, what do I mean by the word ionize? ये क्या होता है? What do I mean by ionize? What you have to do is this point number 7. Think about it. Okay, it's your food for thought. This is the second assignment for the day. Think about it, read about it. What does this mean? How do cathode rays ionize gases? You can do a Google search on it. Think about it. I will explain. Okay, I'll explain this. Okay, I'll explain this in Wednesday's class. Okay, our classes happen on Monday, Wednesday and Friday for you guys at 7 p.m. So on Wednesday 7 p.m. class, I'll explain this concept as well. Okay, fine. Alright, so this is the idea. And the source of cathode rays, you will be able to understand once you understand cathode rays ionizes the gases, so on and so forth. Fine. So we understood the properties, we've understood a lot of things about cathode rays. Let me summarize what we've learned today and then give a very interesting conclusion. We will build onto that conclusion, we'll build onto these points in Wednesday's class and we'll understand how this led to the discovery of the electron. So listen to me carefully. What we did was we wanted to create a discharge. Yeah, we wanted to create a discharge in the laboratory similar to a discharge that happens in the thunderstorms. Yeah, and once we did that, we saw that there are certain rays that are traveling from the cathode to the anode, so we called them cathode rays. Fine. Now these cathode rays, we understood logically and by doing some experiments that these are negatively charged rays. These consist of tiny particles. They are moving in a straight line. Yeah, they glow, they end up making the zinc sulfide screen glow. So particles with some energy, with some velocity, moving in straight line, deviate in the electric and magnetic field, negatively charged. Very good. And as a scientist, I assumed earlier, okay, I assumed that if I take different electrodes, if I take different materials of the electrodes, let's say in one case I have iron electrodes, in one case I have aluminum electrodes, in one case I have magnesium electrodes, in one case I have platinum electrodes. Yeah, so different experiments, different electrodes, and also different experiments, different gases. I take hydrogen gas in one case, I take helium gas in another case, I take nitrogen gas in some other case, oxygen gas in some other case, and in these different materials that I've taken, I assumed that I would get different type of cathode ray particles. अगर मैंने material अलग लिए हैं, तो particle अलग होने चाहिए. And if the particles are different, their deflection will be different, their speed will be different, etc., etc. Okay, but what was observed in nature, and this is where nature starts to show its prowess. This is where nature starts to tell you that nature is the boss, you are just a dumb human. It was observed, okay, this is an observation. It was observed, and this is an observation, that regardless of the material taken, no matter which material you take, no matter which gas you take, the particles will be the same. If I do an experiment with iron electrodes and hydrogen gas, if I do an experiment with platinum electrodes and helium gas, in both of these cases, the cathode rays are absolutely the same. What? Different particles, different gases, but the cathode rays are the same. ये कैसे हो गया? Yeah. Imagine how this actually feels like to a scientist who's doing this experiment for the first time. Thomson and Crook were doing this experiment. Thomson was doing this experiment. Crook's apparatus was being used. But the thing is, if you're doing this experiment in the laboratory for the first time, what does it feel like? It's like you cut a mango and you get apple seeds out of it. You cut an apple, you get apple seeds out of it. You cut an orange, you get apple seeds out of it. You cut a tomato, you get apple seeds out of it. No matter what you take, you're getting the same type of ray. Oh damn, what does this mean? Does this mean that all of these materials, that all of these elements, all of these compounds have something similar in them? There's something that's the same which is making up these elements. समझ रहे हो? There's a certain particle that exists in all the elements. There's a certain particle, there's a particular particle that exists everywhere. Yes or not? Yeah? Isn't it? Aryant, if you're interested in studying, then that is something that shouldn't bother you. आप पढ़ने आए या पॉलिटिक्स करने आए वो आपकी मर्जी है. Okay? Yeah, what do you think? If I cut 3-4 different types of fruit and I'm getting apple seeds out of every fruit, it means that apple seeds are a fundamental particle of nature, isn't it? It's something that exists everywhere. Apple seeds make up these fruits. Yeah, apple seeds are fundamental to the existence of fruits if I cut every fruit and get apple seeds. Similarly, if I do this experiment on different materials, if I do this experiment on different gases, and I'm getting the same cathode ray, if I'm getting the same particles coming out of the electrode, coming through the gas, it means that this particular negatively charged particle exists in each and every element. I can say that this negatively charged particle that I've just discovered is a fundamental particle of nature, isn't it? I'll repeat this statement in Hindi as well कि अगर एक चीज मेरे को हर एलिमेंट में मिल रही है, क्या मैं कह सकता हूं कि ये सब चीजों में है? I mean, sorry, I am very bad at framing meaningful sentences in Hindi. मैं गप्पे मार सकता हूं हिंदी में, but trying to explain things is a little difficult for me. I'm sorry. Yeah. अगर एक what do you say particle? I don't know. अगर एक पार्टिकल हर चीज में मिल रहा है तो क्या मैं कह सकता हूं इस दुनिया की बुनियाद उस पार्टिकल में छिपी है? Something like that. Yeah. So the particle that I'm talking about, that we've just discovered in this experiment, is a fundamental particle of nature. It exists in everything. This negatively charged particle came to be known as the electron. This is the particle that came to be known as the electron. Okay, this is how the electron was discovered. We found out there's a negatively charged particle that exists in every damn thing. And that was experimentally conducted like this, like the way I showed you today. So now the final thing that I'll show you is a video of a professor in some foreign university actually showing this experiment to his students. And that is the end of today's class. After that, we will say bye-bye. ठीक है? तो चलो मैं वो आपको दिखा देता हूँ. Just let me try to load that video in the software over here. Just give me a couple of seconds, please. Yeah, so I won't play the entire video. I'll just show you some snippets of the video from the middle. You can see how this experiment can actually be done in these days in just this much of space. Yeah, अभी देखते हैं इस चीज को. So this is a video that I'm showing you, and it is from LHS Atkins. Okay, that's the channel. Yeah. And what you see in this professor's hand is the Crookes tube. Fine. What you see in this professor's hand is the Crookes tube, and you will see how this guy takes a certain electrical appliance, I shouldn't call it appliance, apparatus, and does the experiment. देखो कैसा दिखता है ये.
That's mostly evacuated, meaning most of the air is taken out of it, and it's got an electrode on this side. It's generating a lot of voltage as it spins because it's a strong magnet. In fact, if I hold another magnet up, people always ask what will happen if you touch it, and the answer is you'll die. That's why I am now dead. A little bit uncomfortable. But in any case, here's what happens when you hold it across a Crookes tube. Everybody see that? You see it over there on that side? Everybody see it? Pretty cool. I actually can't see it from my side, but I assume you're seeing a straight green line. Mostly.
Why can't you see it?
Because I'm looking from behind. That white screen's only on the front. It's set up to be viewed from one side only. All right, now, this is kind of interesting. Watch this. Is anything happening?
Okay, so I think that's demonstration enough, and you can check out that video later on YouTube. You saw the title Crookes Tube and Electrons, and it's from the LHS Atkins channel. You can check that out. Kudos to them for making this. This is how it can be done in real life. Yeah, you don't even need to complete the circuit. There's one particular end at the normal level, and the other particular side of the Crookes tube, the other electrode, you can put a very high potential difference onto that. Yeah. So yeah, that was nice. Cool. Mazedar tha. And when you bring a magnet next to that Crookes tube, the deflection also was visible. Yeah. So that was a very fun way to do this experiment, and yeah, fun way to discover electrons. So I hope you enjoyed the discovery of electrons with me today. I have to take another class at 8:15 p.m. and that's for the solid state. So I'll take your leave right now. But the thing is that now you guys will have a lot of doubts coming into your mind. Yeah, sir, I have some more things to ask you. Sir, what about this? So on and so forth. So do one thing, please. Please try to write down your doubts in your notebook. Okay, write down your doubts in the notebook. What we will do is in the next class is on Wednesday at 7 p.m. Same time, same place. Okay, Wednesday at 7 p.m. The first thing that we'll do in that class is we will have a discussion. I will talk to you guys. I will ask you what those doubts are. We will try to go through those doubts. You please read the NCERT. Please research things online. Try to explain things to yourself as best as you can. Even then, if there are doubts, I will explain those to you Wednesday at 7 p.m. Before leaving, however, I would love to remind you that we are running this very interesting offer on the Unacademy subscription, where if you buy 1 year of Plus subscription, then you get 2 months of free, and 2-year Unacademy subscription, you get 3 months for free. Yeah, very useful offer for you, and the prices are over here. If you enroll in the Plus subscription using the code PAHUL, then the cost for 1 year is less than 3,000 a month. That is very cheap compared to what you will earn if you get into a good college and get a good job later. Yeah, so this is good investment because brilliant teachers are teaching on this platform, and if you want personal guidance, then you can take the Iconic subscription. Plus subscription plus personal guidance is Iconic subscription. Fine. So Gurpreet is saying, will you not teach the chapter 1 of chemistry? I will teach it later. For now, you please simply read it from the NCERT. Okay. Abhinav, don't worry. If you understood today's class, 9th and 10th chemistry, there's no use of it. Don't worry. It's fine. Chalo ji. People, that's it from my side in today's class. I will see you on Wednesday. Please subscribe to this channel right now. Hit the notification icon. And yeah, that's it. See you soon. Bye-bye.